In this video, we're going to be talking about rational functions. And as is the case with this rational function, we have two asymptotes here, a vertical asymptote and a horizontal asymptote. The vertical asymptote in green is at x equals -1 because the denominator of our rational function is undefined when x is equal to -1. So it's impossible to plug -1 in for x there and get an output because it would be undefined. And so our rational function also has a horizontal asymptote where y is equal to 1. And what I want to do is kind of move some stuff around here and show you how things change. So I'm going to leave the denominator alone. Well, I'll change the denominator first. Let's make it x plus 2. Now notice that my horizontal asymptote is still valid in blue, but my green is no longer working. I need to flip that over to -2 because now my denominator would be undefined where x is -2. Okay, if I make this a 5, my horizontal asymptote will be at x is equal to -5. If I make it x minus 4, like that, now it's going to be x equals +4. Because again, 4 minus 4 would make the bottom undefined. Okay, let's change another thing. If I make the top negative, notice that my vertical asymptote is the same. It's still x is equal to 4, but my y equals my horizontal asymptote has to flip as well, become -1. And we also notice that the function, I'll delete it here real quick and take a look, and then put it back in, it flipped. As we've noticed when we put negatives in things, it flips up and down. It has a reflective symmetry, if you will, up and down. So I'm going to make it positive just to kind of keep talking about this, and that makes this go back to being 1. I'm going to start putting some numbers in front of here. What if I make this a 2x? Well, my green, my vertical asymptote is still the same, but this is now at 2, my horizontal asymptote. If I were to make this 4, my horizontal asymptote is also at 4. If I put a 3 down here, so I make this 3x minus 4, my horizontal asymptote is now at 4/3. Okay, if I put this at 10 and make this a 5, my horizontal asymptote is at 2. 10 divided by 5 being 2, if you didn't notice that. What if I were to make it, let's do a 14 here, sure, and then we'll make it 6, and then so we would be at 14/6 for my asymptote there. Okay, and so you can see how these asymptotes change based on how things change here. I do note that my vertical asymptote is different, and that is because 4 is no longer the number that makes the bottom 0. Instead, that number is now 2/3. 2/3 times 6 is 4, and then 4 minus 4 would be 0. Okay, and so that's where our asymptotes would be. So our, again, vertical asymptote, and why don't we go ahead and write this in. So vertical asymptote occurs when the denominator is equal to 0 and horizontal asymptote occurs at the fraction created by the leading coefficients. But there's a caveat here, and it's only when the functions have the same degree. So both of these are to the first power. So let me change this. If I make this to the second, ooh, things look a little different now. But if I were to make this to the second as well, well, we do have an asymptote again at 2/3 and as well as at 14/6. but we have a third one that we need to talk about, and we'll get more into that tomorrow. So I just wanted to show you that this is only true, this down here about horizontal asymptotes is only true when the functions have the same degree. Okay, for now we are done.